Hey Ariel, so I'm not sure what you mean by like remembering box plots and ratios, but I'll do a quick summary of what I think you need to know. So box plots, uh, in order to draw a box plot, you need five special numbers, and they call it the five number summary. Okay, five number summaries are: you need a minimum, so that's number one. You need the next one, the 25th percentile, which is called Q1 or quartile 1. Then you need the 50th percentile, so the middle, that's known as the median. So middle. Then you need the 75th percentile, which is known as Q3 or quartile 3. And then the last one is the maximum, which in a way you could kind of think of as like 0% and 100%. So if you drew it on a number line, can you see how it's like 0% and then say 100%? Halfway is 50%. So this is median. And then halfway in the bottom half, okay, is 25%. And then halfway in the upper half is 75%. Yeah? And remember the importance of 25% to 75%. So the distance from Q1 to Q3, that distance from here to here is the box. But that box is also telling you the IQR, which is interquartile range. And I tried to explain this to you in person last week, where that is the 50% of the data. Can you see how 25 to 75, that's 50%, yeah, from here to here. And that's a better 50% than, say, if you took the bottom half to represent the class, for example, or the top half to represent the class. Because if you had a class, right, and you wanted to pick 50% of the students to predict for them, it would be unfair if you pick the bottom half, because then they're always generally performing worse. If you pick the upper half, then the 50% of the upper half, then they generally perform really well. So you want to pick the middle 50%. So how do you get the middle 50%? Well, you get it by splitting it up into quarters. So 0, 25, 50, 75, and 100. So you can get 25% from here. So the bottom half, you take half the lower group, and you take half the upper group. And that's why that there represents 50%, but that's a middle 50%. And that's why we look for the interquartile range. So in summary there, you can then say IQR, or the middle 50%, so middle 50%, you can find it by finding the distance from 75th percentile minus 25th percentile, or think about it as Q3 subtract Q1 will tell you how far it is. Okay, so that's IQR there, and then you need to know outliers. So how do you know if someone is beyond the general group of people? So if a class of students were usually getting let's say 40% on average, and then a kid gets 100%. Is that kid still part of the class, or are they very different from the class? And how do you know that? So to work out outliers, there's two formulas, and it's worthwhile that you copy this down. You should have like a bound reference or something, or set of notes. But for this one, you should write down lower boundary, which is equal to Q1 minus IQR times 1.5. Okay, and what that just basically means is that, you know how we were talking about just now, we were saying Q1 is the 25th percentile and Q3 is the 75th percentile. So there's a minimum 0 and the maximum is 100%, right? And then the median somewhere in the middle. what you're doing is you're taking Q1, see, Q1, and you're saying minus, which means goes this direction, minus IQR. Now, what does IQR mean again? Remember, IQR is the middle 50%. So you're taking this group of people, so most of the people in your class, and you times it by 1.5, which means 150%. That's what 1.5 actually means. So 150%. You're subtracting the same group of people, but further down. So 150% of them, so like that. And then it draws a boundary. So if anyone who scores even less than that must be now out of the group because you've done 150% worse. Get me? So 150% worse. So if everyone generally scores between, say 30 to 40, that's a difference of 10%. Okay? And what we're saying is, well, let's take the lowest person, so whoever's sitting at Q1, and we go further down this way. So if it's 10%, then we do 1.5 times. So we go 10% again. So that's now 20 to 30. And then we do another 0.5% because we're doing it 1.5. Yeah, so 150%. So you go 100% of itself, so one down, and then another 50% of 10%, so another 5% down. So that means 30. I'm going to subtract by 10% again because that's one group of the IQR plus another 5% that you're subtracting further. So in total now, anyone who scores, so 30 minus 10 minus 5, that gives you now 15%. So anyone who's scoring less than 15%, okay, is way too further away from the actual group. So everyone's getting around 30 to 40. And if you're now scoring less than 15%, you're considered an outlier. So how did I work that out? I just simply took IQR. So I said, all right, well, let's say the middle of the top half is 40. So Q3 minus Q1, which is 30, and I get 10. Then I said, all right, well, take the lowest person. So IQR is equal to 10 now. Lowest person scored 30. Okay, so the middle of the lowest group, 30. Take away IQR, which is 10, times 1.5. Now, if you do that on your calculator, it's 30, take away 15. And that gives me 15. So that means lower boundary, anyone who scores less than 15 is considered an outlier because they're not in the same group as everyone else. Okay, so again, if you didn't understand what I was just trying to say there, maybe you just need to memorize this formula or write it down. Anyone who scores lower than that boundary, so Q1 take away IQR times 1.5, is considered an outlier. And then same thing, the upper boundary. So if anyone who now scores above what we expect. So if you think about this picture again, okay, so if our class often only gets 30 to 40% for their whatever test, right? Then that's the IQR is only 10%. That's the width, right? That's where everyone sits between. There's a 10% width. So then what we do is we take the upper half, so the middle of the upper half, we say whoever was sitting at 75th percentile, say Q3, and we're going to go further this direction. I'm going to say, all right, well, let's see anyone who scores way above what everyone else is scoring. So Q3 plus, because we're going to the right, and I do the same thing, IQR times 1.5. So if you work it out, Q3, which is currently in this example, is 40. IQR we worked out to be 10, so 10 times 1.5, that's 40 plus 15, and that gives you 55. So anyone now who scores above 55 in this particular classroom, so they score above 55, that's the upper boundary. Anyone who scores more than that is clearly very different from everyone else here, because everyone's scoring between 30 and 40. So at what point do you consider as that they're really special or very different from this particular class? Okay. And that pretty much sums up what you need to know for Boxplots. So you need to know IQR, how to calculate it. and that's just 75th percentile take away 25th percentile, or Q3 minus Q1. And then you need to work out outliers. And outliers is just really, you need the IQR, and you either go above or you go below the 25th or 75th percentile. So really, you always need to find the 25th percentile and go really low to find the outlier, and then you need to find the 75th percentile and go up, and that will tell you the upper boundary for the outliers. Okay, just to give you an idea, let's do an example. Let's say let's do the example. So 30 is the smallest percentage I got. The maximum percentage I got is 40. And let's say, actually, no, I'll do 10, 30, 35, and 38. Yeah, we'll just do 5 numbers. Okay? All right. Now, if I asked you, I say, how many numbers do I have? You'd say 1, 2, 3, 4, 5. And I say, so who's the middle? Who scored the middle in this group? So my class only has 5 students. Actually, I shouldn't do 40. I should do 70. Okay. So these are my scores in the class. I got 5 students. I got a kid who got 10%. I got a kid who's got 30, 35, 38, 70. So if I asked you who scored who's the middle in my class, if I ranked them, hopefully you can see that the student who got 35% is my middle student. So that's my median. So that's 50th percentile. Then that student cuts in the middle. So that means this is my lower half and this is my upper half. True? So I got 2 kids on the top end and then 2 kids on the bottom end. Then I find the middle of the bottom group. So who's in the middle between 10 and 30? And then what score? And then what's the middle number on the upper half? So this is the 25th percentile, and this is the 75th percentile. True? Clearly 10 is my minimum, and 70 is my maximum. True? So in this case here, now your job is to find what's the middle of 10 and 30. So middle of 10 and 30, add them together, and then divide it by 2. So 10 plus 30 is 40. So the middle of 10 and 30 is 20. And then what's the middle of 38 and 70? So same thing, 38 plus 70 divided by 2. I don't know what that is. That's 108, so 54. Okay. So now I've got my numbers. I've got the minimum. So if I draw a number line now, so the minimum was 10. And I've got, where is it again? 20, 25th percentile. So 20 is my 25th percentile. My middle is 35. So here's my middle. And 75th percentile is 54. So let's say 54 is a bit further up here. 54. So here's my box. Connect the dots, lines, sorry. And then maximum is 70. Obviously, I'm meant to draw this to scale, but you get the idea. Okay, so now that I got my box plot, before you finish, you got to check if there's any outliers. So usually the questions will get you to find outliers. So to find outliers, you need IQR. Now IQR is Q3 minus Q1. So you want to look at the distance between the person who should score 25% and person who should get 75%. You want to know how far it is. Okay, so really Q1, which is 20, and Q3, which is 54. So 54 take away 20 gives me a distance of 34%. So that's the range. That's what the middle 50% of the data, that 50% of the data is about 34% in distance. So 20 to 54 is 34%. So if you want to know the outliers, then this is what you do. You then say, okay, so lower boundary is Q1 take away IQR times 1.55. And our Q1 is 20 take away. So whoever scored 20, I'm going to go further this direction by 150%. So IQR is 34 times by 1.5, and whatever that is That's your lower boundary. Okay, so do I have a quick calculator? Where's the calculator? Calculator. Okay. So let's do, what do we want? 34 times 1.5. So 34 times 1.5 is 51. So I'm doing 20, take away 51. And you have to score negative 31% in order to be like in the outlier. But clearly, if this is a test, you can't get negative 31%. So we don't have to worry about this. No outliers here. So no outliers. And then you check the top end, so upper boundary. And it's Q3 plus IQR times 1.5. And same thing, Q3 was 54, and you're plussing 34 times 1.5. And really, we already know 34 times 1.5 was 51. So 54 plus 51, that's now 105. And again, someone has to score beyond 105. They have to pass 105 in order to be considered an outlier. So in this case, no outliers, and that's your box plot. Okay. If you have an outlier, then that's when you have to put a cross, and then you need to put a new dot for the maximum. Okay. So for example, if 70 was a outlier, you put a cross. And then the next number that you have, that's your new maximum. You put a dot there. Okay. But that summarizes all the skills that you need to know for box plots. As for ratios, I'm not sure what you're looking for. I'm assuming you're saying like most times they ask you to do things like 2 to 4, simplify it. So simplifying it would be finding a common factor. So it becomes 1 to 2. Divide 2, divide 2. For example, if you have 5 to 15, then this now becomes 1 to 3. That's ratios. Unless you mean, say, if you and I were to buy a lottery ticket, okay, you put in $1. So Ariel, you put in $1, and then Mr. Tran puts in $2. So obviously I put in double the amount that you got. Yeah? So that's a 1 to 2 ratio. You put in $1 and I put in $2 to buy this ticket. So the ticket was $3, so you contributed $1, I contributed $2, right? But let's say what happens is this ticket, we won now $1 million. It'll be unfair if you get $500,000 and I get $500,000 when clearly I put in a lot more money than you did. Yeah? It's like, why do you get 500 when you put less than what I put in? That's unfair. So now we have to split this 1 million so that it's fair that because I put in $2, I should get more than you, right? So how do we work that out? So with $1 million, okay, 1 million, I like to draw boxes. You put in $1, I put in $2, which is double the amount that you had. So this is Tran, and this is Ariel. So Ariel, you should only get 1 bit of it, and I should get 2 bits of it. So that means you essentially get 1 out of 3 boxes, equal parts, and I get 1/3 plus 1/3, which means I should get 2/3 of the amount. Okay, so whatever the total amount is, which is 1 million, okay, so it's 1 mil, I should get 2/3. So Mr. Tran gets 2/3 of 1 mil, and Ariel should get 1/3 of 1 mil. And that's a simple calculator thing. You can type on your calculator 2/3 of means times 1 million. So you type that on your calculator. So on my one, where's my calculator? On this one, if I want to do 2/3, so I just do 2 divide 3. There you go, that's 0.66. And then I times that by 1 million. 1, 2, that's 3 zeros, another 3. There you go, 1 million. So how much do I get? I should get 666,000, which makes more sense now. I get $666,000 rather than 500K. Yeah. Whereas how much do you get? Well, you should get 1/3. So to get 1/3, you do 1 divided by 3. Okay, and then times that by 1 million. So you should get 333 1,000. So Ariel, you get 1/3 times 1 million is equal to $333,333. That makes sense. True? Because you only contributed 1/3, then you only get 1/3 of the prize. And I contributed 2/3 of the prize, so I should get 2/3 of the prize. Rather than splitting it in the middle, I get 500K, you get 500K. That's just unfair, right? So that's where we use ratios there. So I used the 1-to-2 ratio. Okay, so I said, how many parts are there? You put in 1 part. So Ariel's 1 part. I put in 2 parts. So it should be 2 equal parts. So in total, it was 1 plus 2 parts. So there are 3 parts in total. So it's out of 3. You put in 1. And then I put in 2. Because 1 plus 1 gives you 2. So I get 2/3. You get 1/3. And then we just do 1/3 or 2/3 of the total amount. So I just did 2/3 of 1 million and 1/3 of 1 million. So that's a ratio problem skill. So maybe that's the one you're referring to. Otherwise, yeah, most of the time you're simplifying or you're solving problems like the one I just described. Okay, so hopefully that gives you a quick summary of ratios and box plots. Hope that helps.